So after sleeping for half a second, there's something that's added to the main dispatch queue. So that's kind of like the main control loop, if you would, for the iPad. And it's going to be processing GUI inputs, it's going to be talking to the robot. So asynchronously, every half a second, this operation is added to that queue, and it's going to run. So the first thing it's going to do is make sure that the robot is, since it's an optional, it's going to check basically that it's not null, that it's actually assigned to a real like living object in the class, which is done when the application first loads. So it should always be there, but the way that this function or this class is set up, it has to be an optional. So it grabs the robot object, and then from the robot object it's just going to read some sensor data. So it's going to get, if the sensors are connected, it's going to try to get the position, and it's going to say that track object is the position, so the tracking camera. And then, so that's just checking if it's connected. So it's not grabbing the position yet, that's just checking if it's connected. So if the tracking camera is connected, which is managed by the sensors object, this connected dictionary at POS position will be true, so it's going to store that value to track. And then it's going to do the same thing again for LiDAR, that's just checking if it's connected to the sensor. So if it's connected, it's going to continue. Well, even if it's not connected, it'll tell you whether or not it's connected. And then it's going to print out, is the robot connected, which is gathered from the robot controller, maintains a variable for the state of that connection. It's going to check if the tracking camera is connected and print that out. Then it's going to print out if the LiDAR is connected. So from in the application, in the terminal, you can see how it actually formats this. It's robot connected, new line T265, which is the tracking camera, LiDAR connected, new line, and then it's going to tell you the current mode of the robot controller. And then after that, it's going to print out the current X and Y values for the robot. So the X and Y values are gathered from the robot itself, just using the encoder values if the tracking camera is not connected. But if the tracking camera is connected, it will actually use that value for the X and Y position. And then same thing with the angle. I forgot to mention the angle. And yeah, that's just polar, or not polar coordinates. It's just Cartesian coordinates, and then it has the direction that it's facing on that 2D grid. And that's the basis for navigation. And then the last thing the dispatch, or in this operation that's done half a second, is it checks if it should play a video. So this is the ViewController object. It controls the main display, so it kind of makes sense to check if the video, or check if it's in range to play a video, or if it's supposed to do that. And so to do that, it checks if the robot's mode is equal to stop. It checks if it's already played the video, and if it's in stop and it hasn't played the video yet, then it's going to check the X and Y position and the angle, and it's going to make sure that the XY position and the angle are close to one of the locations that are programmed in initially. So in the future, well, I mean, this would work even if we completely redo the controls, because it's just dependent on whether or not the X and Y position are in range and the angle is in some range. Right now the range is 36 inches or 3 feet, and the angular range is 20 degrees. So if it's in within 20 degrees of the TOR's programmed angle, and it's within 36 inches of the TOR's programmed position, then it will play the video. So now we're going to go to where it actually, in the future this function will probably be triggered by some QR code reading or some sort of visual information that's slightly more reliable than the position estimate. Or maybe the position, you could use the visual tags to refine the position estimate so that it's accurate enough that this would still work fine, like it normally, or like it already does. So yeah, anyway, let's continue. When it wants to play a video and it's met all of those required conditions, it runs this play video function in the ViewController object. So the play video function is here. So first it's going to check if the video has already been played, and if it has, then it's going to just immediately exit. Next, it's going to check that the video is actually installed on the device, and if the video isn't there, then it's going to print out this error in the debug console, which is the thing down here, which was printing out a bunch of messages earlier. So if the video file can't be found, then that's going to happen, and then it's going to set just these variables to true, and alive it just tells the system that it should stop doing things because the video is playing, and it doesn't have to do any control updates because the robot's already in stop mode. So this just tells everything to it basically pauses all the loops, and then after that it's just going to get the boundaries of the screen, and it just makes a new window over the current one, or I guess it's called a new UI view, but basically it makes a pop-up window over the current window and just plays the video in full screen, and that will happen regardless of the actual dimensions of the video. So if the video's in landscape mode, it'll just maximize yeah, you know what happens. It'll just try to play it as if it's in portrait. So after the video's been played, yeah, so this is just a fancy thing to get it to quit the video when the video is done. And then, yeah, so after the length of the video passes, this dispatch queue function, this will be thrown into the main operation queue, or the main dispatch queue, and then this code will run, which will delete the window that we just made, and it'll set this alive variable to true, which tells all of the loops to continue running. So yeah, in the future, if you want to add the ability to interrupt to the video or pause it, you would have to modify how you would have to modify how it's closed, and then to maybe check if it's been interrupted before closing, and then make some sort of new interrupt display that will modify it'll close it after the video resumes again. So and yeah, that's pretty much it for the video playing. So we've kind of gone over with this main loop update sensor display, is doing. It's updating the terminal display in the center of the screen, which just has a bunch of connection information and the current state of the robot X, Y, and angle. And it's also checking if it should play a video, and then if it should play a video, it runs the play video function. So that's it for the main loop in the